Hello everyone, welcome to this session. Today we are going to learn regarding modeling infiltration capacity, hydrograph analysis. A reasonable estimation of infiltration capacity of a small watershed can be obtained by analyzing measured runoff hydrographs and corresponding rainfall records. If sufficiently good rainfall records and runoff hydrographs corresponding to isolated storms in a small watershed with fairly homogeneous soils are available, the water budget equations can be applied to estimate the abstraction by infiltration. In this, the evapotranspiration losses are estimated by knowing the land cover or land use of watershed. So you can see here this infiltration curve. On this y-axis, the infiltration capacity Fe has been expressed. Here time t expressed on the horizontal axis, and this infiltration curve, you can understand initially infiltration capacity is more. Okay, and as the time passes, this will be go on reducing. But if you plot this particular graph, if you see, this is a showing the cumulative infiltration capacity Fe, okay, which is according to time t, which is plotted. Okay, initially the infiltration capacity, cumulative infiltration capacity, that will be less, and as the time passes, that will go on increasing. Okay, so accordingly this Fc and this Fptc has been plotted here. The time of concentration Tc is defined as the time elapsed from beginning of the rainfall infiltrated into soil layer until it reaches a constant infiltration rate Fc, which is indicated an equilibrium subsurface flow rate. Okay, so in this when you understanding the modeling the infiltration capacity, it is necessary to understand this infiltration curve. So very important is thing that initially the infiltration will be more and that will go on reducing because of the saturation, and this particular curve indicates the cumulative infiltration capacity, and that will be exactly you can say opposite to this, because initially it will be less but that will go on increasing as it is cumulative. Okay. Now again, the same figure shows a typical variation infiltration capacity Fe with time. Cumulative infiltration capacity FET is defined as the accumulation of infiltration volume over a time elapsed since the start of the process is given by Fe integration 0 to t Fet dt. Thus, curve Fet versus time, which is shown in the figure, is the mass curve of infiltration. It may be noted that from this equation Fe 0 to t integration Fet dt is followed that this Fe into t is equal to dFe into t divided by dt. Many equations have been proposed to express the curves Fpt or Fet for the use of hydrological analysis. In this section, four such equations will be described. Practically all infiltration equations relate infiltration capacity Fet or cumulative infiltration capacity Fet with time or and other parameters. As such, many authors find it convenient to drop the suffix p while denoting the capacity. Thus, Fe denotes as F and Fe as F. So, it is very important that so when you are referring the other various books, so this F suffix p it is indicating the small f here, or Fe is at the capital F. So, where this capital Fe that indicates as stated here, that cumulative infiltration capacity, and the related infiltration capacity is Fpt. Now Hutton's equation, as we have discussed earlier as well, which was formed in 1933, Hutton expressed the decay of infiltration capacity with the time as exponential decay, and which is given as Fp is equal to Fc plus F naught minus Fc bracket complete e raised to minus kht, okay, for 0 less greater than equal to t less than equal to tc, okay, where F is equal to infiltration capacity at time t from the start of the rainfall, as we have seen in the curve. F naught is the initial infiltration capacity at t is equal to 0. So initially at t is equal to 0, that F naught is expressed. Fc, that is equal to final steady state infiltration capacity occurring at t is equal to Tc. Also Fc is the sometimes known as a constant rate or ultimate filtration capacity that we have seen. And Kh, it is Hutton's decay coefficient, which depends upon the soil characteristics and vegetation covers. Okay, that will have to see what kind of soil characteristics there, and that depending upon that Hutton's coefficient will be decided. The difficulty of determining the variation of three parameters F0, Fc and Kh with soil characteristics and antecedent moisture conditions preclude the general use of above equation. In hydrological calculations involving flood, it is found convenient to use a constant value of infiltration rate for the use of duration of the storm. The defined average infiltration rate is called as a infiltration index. Please remember this. And two types of indices are common in use. Now infiltration indices, we have already we have seen regarding the two indices. In hydrological calculations involving floods, it is found convenient to use a constant value infiltration rate for the duration of storm. The defined average infiltration rate is called infiltration index, and two types of indices are common in use. Before that, again we will have to see the hydrograph and the surface runoff characteristics. You can see here, okay, on the x-axis the rainfall intensity is marked here in centimeter per hour. We have already seen this, and this particular curve is the infiltration curve that we have seen. Initially it is more and that go on reducing, and time in hour. So you can if you see the hydrograph, okay, so this is called as a above this infiltration, it is a surface runoff. Okay, please remember this is a surface runoff. And if you see the other figure here, the same indicated here. So this particular line, okay, this is the infiltration capacity, remember, and this line between the surface runoff and that indicates the phi line. Okay, and we are discussing regarding the phi index and W index. Now what is phi index? You can see the figure again here. Okay, on the x-axis the rainfall intensity is marked here, centimeter per hour, okay, which is indicating the hydrograph here again. Then on x-axis the time is given. Okay, these are the various vertical bars are there, and these are the losses which are indicating as the phi index. Okay, and this is the runoff. This is the runoff above this line. Okay, the phi index is the average rainfall above which the rainfall volume is equal to the runoff volume. The phi index is derived from the rainfall hydrograph with the knowledge of the resulting runoff volume. The initial loss is also considered as infiltration. The phi value is found by treating it as a constant infiltration capacity. If the rainfall intensity is less than phi, then infiltration rate is equal to the rainfall intensity. However, if the rainfall intensity is larger than phi, the difference between the rainfall and infiltration in an interval of time represents the runoff volume as shown in the figure. This particular runoff volume, you have to focus on that. Now again, if you see the amount of rainfall in excess of the index is called as the rainfall excess. So you can see the excess rainfall is shown here. In connection with the runoff of flood study, it is known as effective rainfall. The phi index thus accounts for the total abstraction and enables magnitudes to the estimated for a given rainfall hydrograph. A detailed procedure for calculating phi index for a given storm hydrograph and resulting runoff volume is as follows. So let us see what is the procedure. Okay. The procedure of calculation of phi index. Consider a rainfall hydrograph of event duration d hours and having n pulses of time interval delta t such that n into delta t is equal to d. This is a equation, clear equation. Let II be the intensity of rainfall at ith pulse and RD is equal to total direct runoff. Okay, so try to know the parameters here. II will be the intensity of the rainfall at the ith pulse, and similarly RD is equal to total direct runoff. So total rainfall P will be that will be summation of II into delta T. If phi is the volume of phi index, then P minus phi into T is equal to RD, where the small T suffix E, duration of rainfall exists. Okay, so this terminology that we will have to remember, and from this basic equation, all this phi index will be calculated. If the rainfall hydrograph and the total runoff depth RD are given, the phi index of the storm can be determined by trial and error procedure as given below. First one, assume that out of given n pulses, m number of pulses have rainfall excess. Here we have to note down that m is less than equal to n. Select the m number of pulses decreasing order rainfall intensity II. Second, find the value of phi that satisfies the relation RD is equal to sum of into bracket II minus phi into delta T. Here the limit you can understand this IN M. Using the values of phi in the step 2, find the number of pulses MC which give rainfall excess. Thus the MC is the number of pulses with the rainfall intensity II greater than equal to phi. Fourth one, if the MC is equal to M, then phi of step 2, here this particular, is the correct value of phi index. If not, repeat the procedure step 1, this process, onwards with a new value of M. The result of step 3 can be used as a guidance to the next trial. Now we have to see the W index. In an attempt to refine the phi index, the initial losses are separated from the total abstractions and average value of infiltration rate called W index, and that is defined by this particular equation. But before that, again we will have to concentrate that the total abstractions and the average value of infiltration rate, okay, associated with that W index is there. So W is equal to, this equation also we have seen, P minus R minus IA divided by T, where P is equal to total storm precipitation in centimeter, R is equal to total storm runoff in centimeter, I is equal to initial losses in centimeter, T is equal to duration of rainfall excess, that is total time in which the rainfall intensity is greater than W in hours, and W is equal to defined average rate of infiltration in centimeter. Since IA rates are difficult to obtain, the accurate estimation of W index is rather difficult. The minimum value of W index obtained under very wet soil conditions, representing the constant minimum rate of infiltration of the catchment, is known as W minimum. Please remember this terminology. It is also noted that both phi index and W index are varying from storm to storm. That is very important. Now, computation of W index. To compute W index from a given storm hydrograph with known values of I, A and R, the following procedure is followed. What is the first one? Deduct the initial loss IA from the storm hydrograph pulses starting from the first pulse. Second, use the resulting hydrograph pulse diagram and follow the procedure indicated in the phi index. Thus the procedure is exactly same as the determination of phi index, except for the fact that the storm hydrograph is approximately modified by deducting IA. Okay, this is regarding the infiltration capacity associated with the index. The relative the examples are also we can see in the notes with you, and make the practice on that. When you calculate yourself all the values, so you will become familiar with all the terminologies in the more effective manner. So thank you for joining these sessions. We'll stop here.